In our day-to-day life, we come across many figures and shapes, especially triangular shapes, traffic signboards, sailing board, a piece of pizza. These are some examples of triangular shapes. In this section, we are going to deal with the area, that is, how to find the area of a triangle using a different approach. You have studied formula for finding the area of a triangle in previous classes. Before going to discuss area, let's see the classification of triangle on the basis of sides. We know triangles are classified as equilateral triangle, isosceles triangle and scalene triangle. Let's have a recap of the three triangles. Equilateral triangles. Equilateral triangles are triangles in which all the sides have the same length. Now what are isosceles triangles? Isosceles triangles are triangles in which two sides have the same length. Now what is a scalene triangle? Scalene triangles are the ones in which all three sides have different length. Generally, we use the basic formula to find the area of a triangle, which is given by area is equal to half into base into height. Let's solve one problem using this equation. Find the area of an equilateral triangle PQR with side 10 cm. Let's see the solution. First, draw an equilateral triangle with side 10 cm. Next, find height by taking the midpoint of QR as M and join it to P so that we get QM is equal to 5 cm. Now, PMQ forms a right angled triangle. Now, we have to use Pythagoras theorem to solve for length PM and then find the area. PQ square is equal to PM square plus QM square, or you can write PM square is equal to PQ square minus QM square. Now substituting the value, PM square is equal to 10 square minus 5 square. PM square is equal to 75, or we can say PM is equal to square root of 75, that is 5 root 3 centimeter. Now find the area of the triangle. Area of the triangle PQR is equal to half into base into height. Now substitute the values in the equation. We get half into 10 into 5 root 3 and we get the answer as 25 root 3 centimeter square. So similarly, one can find the area of any triangle, whether it is isosceles or scalene or right angle triangle, following the same procedure as we did for the equilateral triangle. So the point to remember is that one must have an idea about the base and the height. Now let's see the pros. If height is given directly, area can be found out easily. While what is the cons? If height is not given directly, area calculations become complex. That is, one should seek some means to find the height and then use it in the equation to find the area. So let's have a recap of what we have learned in this section. To sum up the things, we have discussed the classification of triangles on the basis of sides and the method of finding area using the base height equation. And we have seen the equation area is equal to half into base into height.